Hi guys, the video you're about to look at is going into how to solve problems in binomial distribution. This is a series that I'm putting together that covers a bunch of different stuff that you're going to face if you're using Excel to solve problems in statistics. Certainly if you're a student and you're taking a statistics course, what you're going to see here is going to be invaluable stuff for you. How to be able to solve complicated statistics problems using just a couple of clicks. Each of my statistics videos is really going to be like three components. The first part, I'm going to go into what it is. This one is on binomial distribution. So the first part of the video will be kind of a mini lecture that tells you what a binomial distribution is and how it might be used. Then the second part is going to be showing you an Excel document, a spreadsheet, using the built-in formulas in Excel to go ahead and solve problems in binomial distribution. And the last portion of it is going to be a few sample problems. And in those sample problems, you'll see how the statistics is used in Excel using the built-in functions that are there. So one thing of note is the videos are going to be fairly long because they're going to go into, in simple language, what it is you guys need to do to solve the problems in the particular function that we're talking about. So next step here is to actually get into the lectures for you. This video is to instruct you on how to use the binomial distributions function in Excel. And binomial distributions are something that occurs a lot in real life, business, certainly in statistics, and a lot of times in things that you're going to be doing at home. My picture over on the right-hand side, I'm Ron, and I've been teaching statistics for some time. And my hope is that this step-by-step, easy way to look at binomial distributions will make things easier for you and allow you to get through what might be difficult problems in a relatively short period of time, using, in this case, the binomial distribution function that's in Excel on your device. So doing that, you should make your life a lot easier when you're faced with solving a binomial distribution. By the way, all of the videos that I've put together, if you look where the arrow is pointing, you can go to my website, write that down, the address, and if you go there, you'll have a listing of all of the videos that I've put together. If you please would remember to subscribe to the channel before this video is over or at the end, you would automatically be getting each of the videos that I post as I post them, and it would be as very helpful to me if you did that. And any comments that you wanted to make, you also included in the comments section underneath this video. So we'll get rid of my picture and we'll put up the old Excel schoolhouse, where hopefully that's where you're going to be learning on how to do all of these various functions. And we'll start out, as I said, using the binomial distribution. There's four things or properties that identify what a binomial experiment is. The first is that the experiment is going to consist of a sequence of identical trials. And I've said n identical trials. N could be any number that you choose, or it could represent a group of numbers, as you'll see later in this video. With each one of the experiments, there's only two possible outcomes: success or failure. And that could be defined as true or false, yes or no, success or failure, any two outcomes. The probability of success in each case will be denoted by the letter P, and it doesn't change from trial to trial. and each of the trials are independent of the other. So in a binomial distribution, our interest is in the number of successes occurring in the n trials that we're going to go through, and we're going to express our answer as a probability or a decimal that could easily be changed to a percentage. We're going to let x denote the number of successes occurring in the n trials. Now, the next slide has the formula that you would use to calculate this manually. And I say but with a lot of doubts because, I hate to even show it to you because it scares most people. If you had to go through and calculate this manually, you're probably looking at maybe 15 or 20 minutes. And so we're going to automatically give that a thumbs down. Because if you're like me, and I'm using this tongue-in-cheek, you're lazy. Why go through a long and drawn-out calculation when we can use the power of Excel on our iPad or on our PC to solve the problem for us? And so what we're going to do is we're going to take a look at an example, a sample question. And this is a sample question from a fictitious company, Smith Computer Parts. The management of the company is concerned about a low retention rate for their employees. They've seen a turnover of 15% of their hourly employees every year. Thus, for any hourly employee chosen at random, they estimate a probability of 15% that the person will not be with the company next year. In this particular firm, and in so many firms, the cost of training a new employee is substantial. So they'd like to talk with a group of people and hopefully be able to draw from the conversations maybe the reasons why they leave, and then hopefully come up with a way to retain those employees. At any rate, let's say that the Smith Company has 100 employees. They decide, or we decide, we're going to interview 10 of these employees. We know historically that 15% of the employees leave each year. So our question might be, out of the 10 people that we said we're going to interview, what's the probability that exactly 4 of them will leave the company in the next year? Now, that's not the only way we could phrase the question, but to get started with the example, let's just look at exactly 4 leaving the company, where the function of x, the probability of 4 x successes in n trials, is what we're looking to calculate. N, the number of trials, the formula is going to call for that. And we know it's 10. It could be whatever we decided it to be, and we decided 10. P stands for the probability of success. And in this case, success is the person leaves the company. We know that there's 15%. What's the probability that out of the 10 people that we interview, what probability percentage are we going to get of people that are going to leave the company? And so let's move now from this to taking a look at the actual Excel sheet that will allow us to do this calculation with just a few clicks. As mentioned earlier, there are more than one calculation that are usually done when you're doing binomial distribution. To actually come up with the first one, which we already looked at on the Excel document, we use the Excel function binomial distribution. We'll look at some other ways to use that same function in a minute or so, but there's 3 other calculations that are very simple and are usually done on your Excel document, and they're done without using a particular function. And the first is shown there as expected value. The expected value, the formula is n times p. If you look at the bottom of this slide, you'll see that there's 3 variables that are in binomial distribution, n, That's the sample size. In the case of the example that we looked at, we looked at 10 individuals that worked at this computer company, where the probability that they would be gone from the company within the year, that's shown as P, and that was 15% or 0.15. And in the example that we worked on, the number of successes that we were looking for out of the sample of 10 was 4. So N is 10, P is 0.15 or 15%, and X is 4. So now if we go back to our expected value, N times P, N is 10, as you can see, times 0.15, which equals 1.5 employees out of 10 is the expected number of people that would be gone from the company within the year. The variance is the next thing on the list. And the variance formula would be N times P times 1 minus P. Well, N again is 10. P is still 0.15. And then if we did 1 minus 0.15, that would be 1 minus P. That's 0.85. And again, just by doing a simple multiplication on our Excel document, we would get 1.275 as the variance. The standard deviation is nothing more than the square root of the variance. So what we would do here is we would use the square root function of Excel, put square root, and then enter 1.275, and it would return the answer 1.129 to tell us that the standard deviation of this particular binomial distribution is 1.129. The problem we did previously was to calculate the probability that our sample of 10 would have exactly 4 people who would leave the company within the year. And what we did is correct. The problem, and not really a problem, is that would not be how the question would usually be asked. Because what would be more realistic if we wanted to use this data to maybe talk to people and to people that might otherwise have left, we would want to be sure that our sample included enough people so that we could make a valid argument and maybe keep some people who might have left from leaving. A more realistic way to look at that would be is what would the probability of 4 or less leaving be? And as opposed to exactly 4. Also, what's the probability of less than 4 leaving? Now look at those two. One of the problems with looking at those two is a lot of people, when you're in a hurry to get this stuff done, they think that those two statements, sentences if you will, are the same. And as you'll see in a minute, they're not. And if you don't get it right, you're going to get the problem wrong. So this is a case where it's important to take your time when you're going to do the actual calculation. Now those are less than 2 statements. Let's look at the other side. What's the probability of 4 or more leaving? And likewise, what's the probability of more than 4 leaving? And again, if you looked at it real quickly, you'd say, oh, they're both the same. But the fact of the matter is, they're not both the same, and that's important for you to be able to recognize. Because what's our goal? Our goal is to avoid pitfalls when we're solving binomial distribution problems. And take a look at the picture, which a picture's worth 1,000 words sometimes. What you're trying to do is to not get bitten in the butt. And how you're going to do that is if you're asked to solve for less than 4, ask yourself, what is less than 4? Sounds simple? The answer, of course, less than 4 in the problem that we're looking at is 3, 2, 1, or 0. If you were asked to solve for 4 or less, what is 4 or less? It's not the same as 3, 2, 1, 0 because 4 now is included. 4, 3, 2, 1, 0. Different. If you enter the information, as you'll see when you're doing a group incorrectly, you're going to get the wrong answer. If you're asked to solve on the greater side, what is greater than 4? Well, we know that there was only a total of 10 people in the sample. So what's greater than 4? Well, the answer is all the numbers greater than 4, 5, 6, 7, 8, 9, and 10. Likewise, if you're asked to solve for 4 or greater, what is 4 or greater? And this time you have to include 4. 4, 5, 6, 7, 8, 9, and 10. If you understand that and you take your time when you're preparing your binomial information in Excel, you're going to be able to get the right answers. And that's what we're going to look at now. We're going to go into Excel and we're going to apply these things that we just went over, and we're going to look at some sample problems, and we're going to be able to come up with the right answers. Okay, so now we're back in our Excel sheet, and we're looking at what we've done so far, and you can see that we have, when we asked about exactly 4 successes in 10 trials, we came up with the number 0.0401. If I highlight that cell and I direct your attention up to the upper left side of the screen, you'll see where it says equal binomial dot distribution and the numbers. That's what I entered in the Excel function, and Excel returned to me 0.0401, which is a decimal, and it's fine, and it's the correct answer. I could, however, decide to change how I want to look at that. Maybe I do, maybe I don't. While it's highlighted, I unhighlighted it, highlighted it again, and I go to the column in the white menu row that says ABC 1, 2, 3, and I select that. When I select ABC 1, 2, 3, I get a drop-down menu, and one of the choices is percentage. If I tap on the percentage, Excel changes that for me from a decimal to a percentage. It's usually a matter of personal preference. Sometimes you're looking to express everything in percentages. Sometimes you just rather be in decimals. You have the option without changing the value to change how it displays. And just quickly now to go through the expected value, variance, and standard deviation. You remember that the expected value is n times p. So what we're going to do is we're going to say equal. And this is just a little bit different. It accomplishes the same thing. Instead of typing in, or keying in the 10, I'm just going to highlight the 10. Then I'm going to enter the times key. And then I'm going to highlight the 4. N times p. I see that's not right. I don't want times x. So I see that I have entered that incorrectly. No problem. I now hit the red X and it goes away and I can start all over again. Now I'm going to say equal n times, and this time I'm going to do it right and highlight the p. 15%. I'm going to hit the green check and it gives me an expected value, just as we got earlier in this video, of 1.5. Now I'm going to do the variance. And the variance, if you remember, equals n, highlight that, times p, times 1 minus p. Now, in order to do minus or plus in the formula, I need to use the parentheses. So I'm going to say 1 minus, and highlight the p. Close the parentheses. Now when I highlight that, now that it's highlighted and I hit the green check, it's going to tell me that the variance for this binomial distribution is 1.275. I want the standard deviation. It tells me that the standard deviation is the square root of the variance. So now I'm going to say equal and start typing SQ. Square root is shown as SQRT. And tap on that and it says, what number do you want the square root of? Now I can either key in 1.275 or just highlight it. Remember, I told you earlier, I'm lazy, and if I can do it in less clicks, that's what I want to do. I hit the green check, and it tells me 1.12916. Okay, now I told you a little earlier in this video that when you're looking for an exact number, how you enter the binomial distribution to get the right answer. What I need to do now is to do something that's more realistic. Normally, when you're doing binomial distribution, you would use a range. You want to know, if you took 10 people, what's the probability that less than 4 of the people would be leaving the company in the period of time, in this case 1 year. So less than 4, this time I'm going to do binomial distribution, and I'm going to say binomial distribution. I'm going to select it. Now, the number of successes, what did I tell you earlier? Less than 4, what is the definition of less than 4? 0, 1, 2, and 3. So less than 4, the highest number less than 4 is 3. The number of trials is 10. The probability of success is 15%. Now you remember when it was exactly 4, I put false in the cumulative field. I didn't want a cumulative number. I just wanted the number 4. But now I want the accumulation of the value of 0, 1, 2, and 3. So I could enter true. When I enter true, and I'm happy with that, and I hit the green check, it tells me that less than 4 of those 10 people is 0.95003. Now I could change that to a percentage. It would come out 95%, but it's not necessary. Now, if the way it was asked was 4 or less, I would still start out by saying this is binomial distribution. The number of successes, 4 or less. So I am interested in 0, 1, 2, 3, and 4. So the number then that I would have to put in here is 4. The number of trials are 10. The probability of success, this time I'll just enter 0.15. I could have said 15%. And again, this is going to be true because I want a cumulative number. When I hit the green check, it comes out 0.99 instead of 0.95. You say, well, that's not all that far apart. In terms of statistics, it's like a mile. You want to be sure that you entered your data properly. Now, there's a little different twist when you're trying to do numbers that are more than. It starts out the same. We're going to say equal binomial distribution. More than 4. Well, if you want more than 4 and you're going more than, greater than, equal to, or more, you need to recognize that Excel does not calculate more than numbers, which is not a problem because all of the data represents 100%. So if you know that, and you do now, because I just told you, and you say you're going to calculate the highest number you're not interested in, because this is more than 4, the numbers that you're interested in are 5, 6, 7, 8, 9, 10. And you're not interested in 0, 1, 2, 3, and 4. So we're going to put in 4. That's the highest number we're not interested in. 10 trials. Probability of success is still 15%. I'm going to enter this. We're going to say true. And I hit the green check, and I get a number that's wrong. The number is for 4 or less. That's what I just calculated. But if I know the number of 4 or less, and I subtract that from 100% or 1, I'll get the number that I'm looking for. So I could say equals 1 minus, and highlight this, and the number that I get is 0.0099. Now, if you're lazy, and I keep telling you that I'm lazy, and you're doing a more than problem, you could do it only in one step. By recognizing you're going to want to subtract your answer from 1, you start out by saying 1 minus, and now you do your binomial distribution. I forgot my equal sign. Got to put your equal sign. 1 minus binomial distribution. Okay, highest number that we're not interested in this case, is 4. Number of trials that we're talking about here is 10. The probability of success is 15%. And we're going to now say true. And when we hit this, I got an extra parentheses in there that I put in by mistake. I hit the green check, and it gets 0.99%. Well, 0.99%, if I change this decimal over to a percentage, I would get 0.99%. If I want to change this over to compare it exactly, I'm going to hit my ABC 1, 2, 3. I'm going to select number, and then I'm going to increase the decimals by 2. And you can see now that those match exactly. If I want to do 4 or more, I can do, again, I could say equal 1 minus 4 or more, which means that more than 4 was 5, 6, 7, 8. If I want 4 or more to be included, the highest number I'm not interested in is 3. So I'm going to put in my binomial distribution. Number of successes in this case is going to be 3. Number of trials is going to be 10. Probability of success is going to be 0.15. And cumulative is going to be true. And now I'm going to go ahead and hit the green check. And I'm going to get my decimal right away. 0.0499698. I can reduce the size of the decimal if I want to take a couple of spaces out, just the way I've been doing it. I could say decrease the decimal 2 or 3 places, 4 places if I wanted, and make it match the number of places from above. Sounds confusing, maybe, but it really isn't. And it's a question of how often are you going to have to do this stuff, of whether it makes sense to you on an ongoing basis. Again, it depends how you're going to use it. If you're taking a statistics class in school, you got one set of problems. If you're working on stuff at home, you got a second set, and if you're doing it at work, you got a third set. But just as long as you're in a position of taking your time and watch out for those areas that have a tendency to bite you in the butt. You have just watched the video on calculating binomial distributions. Congratulations, I know it's long, and I appreciate that you took the time to get through the whole thing. Please recognize that this video is an essential one for those who are going to be solving statistics problems using Excel on their device. For that reason, there's a statistics section of videos that I put on my website, and the address is there, and you're going to need to write that address down and be able to put that in your browser to access the website. As far as this video is concerned, any comments that you would have, please enter them in the comment section below. If you have any questions about what I've said or you need further explanation, please put that in the comment section. And as soon as I see that you've done that, I will go in there and try to get an answer to you as quickly as I can. What's most important is to subscribe to my channel in order to get copies of new videos as I post them. And to do this, you will need a Google email address. And YouTube will walk you through getting one if you do not already have one. And what this involves is all you would have to do is click on the subscribe button, and it'll look to see if you have a Google email address. And if you don't, just enter the couple of questions that they ask you to enter and get a Google email address created. It'll not only help you with this video, it's going to help you subscribing to any of the video channels that you might want to subscribe to. So I hope that you're going to be excited enough to just do it for my channel, but if not, it's going to give you the advantage of having this to use for any other information that you're trying to get to help you by using the various things that are available in YouTube.